Bismillahirrahmanirrahim. Myself Rafaqat Ali. Today's lecture is about the grade 8 and the date is 16th March. So let's start the lesson. Today's lesson is about the inverse of the matrix. You can see this lesson on page number in the chapter number 9, page number 274. And you can see on the screen the inverse of the matrix. The first thing you should keep in your mind, we will use some terms in this lesson, the inverse and the identity matrices and this kind of thing, square matrix. For example, just keep in your mind, identity matrix is the matrix you can see on the screen when in the principal diagonal all the ones and all other values are 0. This is called identity matrix. This identity matrix is same like 1 in the simple digits, like that when you multiply 1 by any number it will be no change, there will be no change. So this identity matrix behave the same like 1 in the matrices. Whenever you multiply identity matrix by any matrix there will be no change. This is the rule. And let's start now. The inverse of a matrix A is written A inverse. This is the way of presenting A inverse. At the par index you will write -1, it represents inverse of the matrix. And just keep in your mind, this is the universal rule. A into A inverse means original matrix. Whenever you multiply original matrix by its inverse or inverse multiplied by its original matrix, answer will be identity, like this. And there is one condition to find out the inverse. The matrix should be square matrix. Only square matrices possesses the inverse. The rectangular matrix, when the number of rows and number of columns not equal, we cannot find out the inverse. When the number of rows and number of columns equal, like that 2 cross 2, 3 cross 3, 4 cross 4, then we can find out the inverse. For example, if A is equals to A, B, C and D, A, B, C and D are the elements of the matrix. We want to find out the inverse. So first you should keep in your mind, we will find out the determinant. This is determinant. A multiplied by D minus B multiplied by C. Here should be minus always. For finding the determinant, A multiplied by D and B multiplied by C, in between will be the negative sign. And 1 divided by determinant multiply by the adjoint. Adjoint, what is adjoint? You will replace the places A and D and change the signs B and C. You can see now D at the place of A and A at the place of D. And if here is positive, it will become negative. C is here positive, here you can see C is negative. So determinant can be written like this, A determinant. Here the number A, D minus C, B is called the determinant of the matrix and it is written by A. These are the two bars. If A determinant is 0, then the matrix has no inverse. Why no inverse? Because A, if here comes 0, so we cannot find out the value. 1 over 0 is an unidentified value, so we cannot find out the inverse. Now you can see the example. Find the inverse of A. If A is equals to 3, minus 4, 1 and minus 2. The inverse will be, first find the determinant. 3 multiplied by minus 2, you can write here 3 multiplied minus 2. Then here minus, here should be the negative sign. Then 1 multiplied by minus 4. 1 multiplied by minus 4. After that we will multiply what? Change the places, 3 at the place of minus 2 and minus 2 at the place of 3. Then change the signs. Now you can see here minus 4, it will become positive. Here 1 positive, it will become negative. Here negative, it will become positive. Now you can solve. Minus 2 multiplied by 3, minus 6. Then this minus multiplied by this minus will become plus. minus 6 plus 4 equal minus 2. Minus 6 plus 4 equal minus 2. Now 1 over minus 2 into minus 2, 4 minus 1, 2. This is called A inverse. This is called A inverse. You can divide this minus 2 by all inside the values. If you divide, it will be minus 2 over minus 2, 1. 4 over minus 2, minus 2. Minus 2 over minus 2 will be 1 over 2. And the other one, 3 divided by minus 2 will be minus 3 over 2. This is the answer. If you don't want to solve till the next step, so you can keep this A inverse answer until here. Now you can check this. When you multiply this A inverse by the original matrix A, the answer will be identity matrix. So it means that this is the correct answer. Multiplying the inverse of the matrix given the same result as dividing by the matrix. The effect is similar to the ordinary algebraic expression. A multiply B equals C, or A inverse multiply AB equal A inverse C. Means if you multiply AB by C, AB, when you multiply AB, the answer is C. And A inverse AB equal to A inverse C, because AB is equals to C. So B will be A inverse C. In this way, this is the algebraic expression, one kind of operation. So now this is the exercise 12, exercise 2, sorry. Question number 1 to 15. You can solve all these questions up to 15. Question number 15. The remaining some questions in the next lesson I will solve from 16 to onwards, and some questions from 1 to 15. 1 to 15 is your homework. These are the easy questions. We have already discussed in the previous class in grade 7. We had a lot of practice at that time. You can solve easily. Inshallah, in the next lesson I will solve some questions from this, and from 16 to onwards, this exercise we will discuss in the next lesson. Keep in touch. Thank you very much.